I want to start talking about chapter 2 today, which is really a look at the background to how our understanding about evolutionary history began. How, as a discipline, anthropology and biology, science, geology, all of these different ways of looking at the world started to redefine what we thought we knew and what we understood. I want to introduce it to you by taking you back to 1755. In 1755, there was an extremely important event that took place that I think doesn't get enough credit for its importance in modern history. In a place, the capital of Portugal, Lisbon, and a huge earthquake took place, the Great Lisbon Earthquake of 1755. Now, at the time in the 18th century, the Catholic Church in particular, but Christianity in Europe, had dominated knowledge. Their control of the way that we understood the world was very top-down. It was dictated by a religious text, the Bible, and the social and political control over just people's everyday lives was absolute, such that you couldn't really ask certain types of questions. It wasn't allowed, and you probably never would even come up with these questions because you just would have assumed that all knowledge and all the answers that you're looking for are coming from that religious text, divine revelation. That we as humans it's impossible for us to approach knowledge. Knowledge has to be given to us by divine intervention. That was the assumption. So philosophers and learned people never asked uncomfortable questions that anthropology is doing. I'm asking you to ask yourselves. Who are we? Where do we come from? Well, in 1755, the answer was known. It was absolute. There was no question about it. The Bible tells us where we come from. We were created whole cloth in 7 days. Forget about the fact that there's 2 creation stories in the Bible and they kind of contradict one another. Forget a lot of the inconsistencies that the Bible has in it. If you want answers, that's where you find them. And the church, especially the Catholic Church, was an extremely top-down enterprise. But all Christianity sought answers to some of these questions, existential questions like what are humans and where do we come from the Bible and from religion. But in 1755, this very wealthy, very powerful nation of Portugal, which had an empire around the world, in the Indian Ocean and in Micronesia and Indonesia. The Portuguese colonies extended over to the Pacific. They also, Brazil was, and Madagascar and African nations were dominated by Portuguese control. So the Portuguese were a wealthy, powerful European country that thought they had all the answers. And on November 1st, All Saints' Day, as good Catholics, most of the citizenry in Lisbon were in church. 10 o'clock in the morning, something like that. Everybody was praying, as you're supposed to do, because all the answers come from the Bible and from religion. And a massive earthquake struck. If you go to Portugal today, if you go to Lisbon today, almost none of the buildings in the capital are from prior to 1755. The entire city was annihilated, wiped out. And some of the biggest buildings, housing most of the people on that November morning, were in those churches. These giant cathedrals came crashing down and killed tens of thousands of people. And imagine if something like that took place in one of today's major population centers, a huge power center. Imagine a bunch of people in some big major city today, and all the buildings came crashing down. We would be appalled. And as it turns out, people all over Europe were just aghast at what had taken place. But what was more is that the people were doing what they were supposed to be doing. People were in the place that they were supposed to be, on the day that they were supposed to be there. They were doing what the church told them to do. And they still died. These were good people. These were normal people. These were holy people. These were people that were just following their directives. And this event brought on some questions. People were like, how could this happen? How could God allow this to happen? They were just doing what they were told. Were they being punished? Is there something that Portugal did wrong? Were these individual people, these children and men and women, were they responsible for their deaths? How can this be justified? This event allowed people, it gave cover for people to ask questions that had never really been allowed before. They said, I don't think that this is right. What's going on here? Earthquakes, what are those things? And is it really a punishment from God? Should we really be in church? What if we don't? What about all those people that weren't in church? They were doing what they weren't supposed to be doing, and they probably survived that big earthquake. So you started to get philosophers and learned people have the ability to ask questions that they were never able to ask before. This is what an event in European history that we call the Enlightenment, the Age of the Enlightenment. And it really was, this was a big event for it, because prior to the Lisbon earthquake, it was very difficult to ask a scientific question about things like, where do humans come from? Because we already knew, remember? All the answers were in that book. If you were to say, I don't think so, I think that things might have happened another way, then you would be blasphemous. You would be committing a sin by saying, no, I think that it was something else. And if you recall our discussions about what science is the ability to say no. This is where the epistemology of science is different from one of faith. Faith in a religious text, if you want to do that, that's okay, but that's not the place, this is not the course for that. This is the course for you to ask questions and have the ability to say, no, I am incorrect, or this is incorrect. That is the fundamental basis of science, and it's what separates science from religion. The Enlightenment is the backdrop into which a lot of scientific processes started to come about. Our modern scientific understanding is based on European academic institutions deciding on a methodology for approaching, looking at the world and being able to say, I think this about it, but I need to be able to say, no, I'm incorrect about that. This is falsifiability. This is hypothesis testing. You can't say, I think Adam and Eve were created by God in one moment. That's not science unless you can say no. And that's where the reliance on a single book for all of your truths can't be science. If you can't say no to it, it's not science. So This is the sort of European intellectual environment by which new scientific innovations started to arise in the 18th century. And one very important location for the Enlightenment was in Scotland. And my alma mater, actually, I'm still a fellow at the University of Edinburgh, where I run projects, and I'm still an academic there at that institution. It's where I got my PhD. It's my alma mater at the University of Edinburgh. And the University of Edinburgh is where which is the capital of Scotland, is one of the homes of the Scottish Enlightenment. And the Scottish Enlightenment was really about, in a large part, trying to establish rules for scientific thinking. And medicine, the University of Edinburgh's medical school is still one of the top medical schools in the world, but certainly in the 18th and 19th centuries, it was the place to be. But there were also some other scientific disciplines that were starting to arise at this time that may be a little less obvious for physical anthropology, and that is geology. The origins of geology find their roots with Lord Hutton, and then later Charles Lyell, also a Scottish geologist, established the basic rules for geology, and we're going to talk a bit about that today. But there's another reason why I bring up Scotland, not just because of geology and the Scottish Enlightenment. It's also where a young man who did not want to go to medical school, but was encouraged to go by his family, went off to medical school from his home in England and went up to Scotland to Edinburgh to study medicine. He never finished his degree there. He did not like it. Studying medicine, but he was interested in the biological aspects of it. This young man was named Charles Darwin, and he was in his probably 20 years old or something, went up to Edinburgh and was learning medical science at the University of Edinburgh, where just a few decades earlier, Charles Lyell and James Hutton were establishing the rules for geology. So he was learning about biology, he was learning about the geological history of the Earth, and this was his backdrop. Now, he didn't complete his medical degree at the University of Edinburgh because he had an extraordinary opportunity that was presented to him while he was studying. There was a voyage of discovery on a very famous ship. Well, I guess he made it famous in a way. Today we know it is very famous as the HMS Beagle. The Beagle was a trip around the world on a tall ship, and he was brought on board as 22 years old to be the naturalist for the project. Now, what that means is he was just the scientist on board who would make observations and record what they saw. They were going to places no one had ever been to before, and certainly no Europeans had been to many of these places. And he was bringing science with him. So he was to observe, he was to write about and record, categorize, catalog, and draw things. And he drew hundreds and hundreds of drawings of animals and plants and rocks and scenery and all these sorts of things. And this trip around the world was extremely important to him. He spent the next few decades just trying to think about what it was that he saw. And I mentioned in the last lecture that Charles Darwin did not invent evolution. And in fact, he was coming in at a time when these ideas about evolution were already being talked about. The question of how old the Earth is prior to 1755 would have been an easy one to answer. All you have to do is look at the Bible. And actually people went through and they said, okay, based on what the Bible says, the Earth is about 6,000 years old. And so that means 4000 BC, And some people even calculated the moment in time, the day and the time of day that the Earth was created. And these early geologists said, wait a minute, I think that might not be correct. I think that's false. I would like to test that hypothesis. Charles Darwin was aware of some of these innovations in geology and things like the age of the Earth. He was also aware of the diversity of life. He had been around the world and seen different types of life forms. And he saw how they were very similar. They were sort of had the same forms no matter where you went. A bird may look a little bit different in one place, but it's still a bird. You can tell what it is. A fish is a fish, and a mammal is a mammal, and a lizard is a lizard. But they're not all the same. They're not all identical. So he was asking questions like, why? And he wasn't the only one. There were other people that were starting to sort of nibble at the edges of these ideas that had been entrenched in people's minds from an understanding from the Bible that they're like, that doesn't make any sense. Or at least I would like to be able to test that and to say no to it. And they were then allowed in the Enlightenment. Now, I said that Charles Darwin did not invent evolution. He made observations, and he was sort of the right person at the right time in the right place. The place was first Edinburgh, where he got some of his early ideas, and then the Beagle. He was in the right place for going around the world and gathering this data. And then he was at the right time when other people were building up sort of a backdrop for him to be able to synthesize his theory of evolution. It took him decades for him to come up with his magnum opus, his book called On the Origin of Species by Means of Natural Selection. And actually there's a lot in that title. I want you to think about that title because every single word in there is going to be important. On the Origin of Species by Means of Natural Selection. Natural selection is Charles Darwin's major contribution to science. And when we go through what that means, you're going to say, well, that's kind of obvious. And yes, it is. But so are a lot of scientific principles. The theory of relativity is extremely simple concept. I encourage you to go and read the general and special theories of relativity by Albert Einstein. They're actually really pretty easy to read. His mathematics are really good, and he's able to establish some proofs for these. But actually, when he wrote about the theory of relativity, he was saying something that we all kind of recognize already, that there's three dimensions around us, right? I'm not just a flat form that you're seeing on a screen. There's three dimensions. There's depth of field. This is coming towards you, right? But also things are happening in time. And that was really Albert Einstein's contribution to science, or one of his biggest ones, is that things are relative to what time and space. Time and space are relative to one another. And that's something that we observe all the time. It's obvious. But Einstein was a genius because he was able to scientifically establish the way that operates. So in the same way, Charles Darwin was a genius not because he recognized that change happens through time and that things adapt. That was already being talked about. But Charles Darwin had a huge amount of data that he had collected on this voyage around the world as a young man. And he spent decades trying to use that data to come up with a theory that fit and made sense of all of the evidence that he had compiled. And so if it wasn't Charles Darwin, it would have been somebody else. And actually, we even know the name of the other person who it would have been. His name is Alfred Wallace. Alfred Wallace wrote to Charles Darwin just a couple of years before he published his book and said, I've been thinking about this idea about evolution and biological evolution, and I hear you're working on the same thing. And Charles Darwin was like, I better publish or I'm going to be gazumped. And so actually the first presentation of the theory of evolution was done jointly by Wallace and Darwin. to the Royal Society in London. And that just goes to show that Charles Darwin was actually kind of a nice guy. But the reason why we remember Darwin so much is because his book had so many details in it. Wallace was also talking about these ideas of natural selection and evolution, but Charles Darwin had the facts to back himself up. And if it didn't happen at that moment, it would have been by someone else slightly later. So it was just waiting there to be discovered, and all of these Enlightenment ideas were building towards this inevitable outcome. Now, what was it about his trip around the world that got him thinking about evolution? Well, like I said, there were already ideas that were as the backdrop. That first of all, the Earth is not 6,000 years old. By Darwin's time, we understood scientifically that it was millions, actually billions of years old. But what really got him thinking was when he went to a cluster of uninhabited by humans, uninhabited islands in the Pacific called the Galapagos Islands. These are now very famous, but at the time, this was one of the first voyages to discover these islands. And he saw that there was animals that lived on it's an archipelago, so different islands with slightly different environments, different food sources, different pressures, different ecosystems. And what he saw was that there were things like finches, birds, right? That they all looked like they were related to one another, and he hypothesized that a breeding population of finches came to these islands from South America, got off course somehow, and wound up on these islands. And they all were a particular population. They all looked like one another. But then they radiated out to different islands and found different food sources. Some had nuts, some had worms, some had termites, some had berries, some had other types of things, seeds, or seafood. These are all different resources available to each of these finches. But here's the key. To survive in each of these islands, you needed a different kind of tool. So if you've got a big chomping beak, that may be great for crunching open nuts. But you're not going to be able to get that big beak into a little log to get little worms. So depending on what your food source is, you will actually survive better with different qualities, different attributes. He called this adaptive radiation, or descent with modification. So from some original group of finches that flew to the Galapagos Islands, each of the islands started to have differences that modified according to what resources were available. Now, this started to make sense because, like I said, the concept of evolution was already being spoken about in other disciplines. Talk